another edition of math formulas. In this edition, we are looking at this problem. We intend to prove that a real polynomial factorizes into degree 1 and degree 2 factors. For that, we will use the fundamental theorem of algebra, which states that any polynomial with real or complex coefficients has n real or complex roots. So let this polynomial fx be written as alpha into x minus r1 into x minus r2 into x minus rn, where n is the degree of the polynomial. Now this r1, r2, rn can be real or complex. If r1 is real, then of course x minus r1 is a linear factor or a degree 1 factor, and this is true for every real root. So for every real root ri, x minus ri is a linear factor of the polynomial. Now if rj is complex, not real, more specifically, then we know that rj bar is also a root. So rj bar is also present as one of r1, r2, rn. So if rj is a complex root, then rj conjugate is also another root of this polynomial. And therefore, if we take these terms x minus rj into x minus rj conjugate, then we get x square minus rj plus rj conjugate x plus rj into rj conjugate. Rj plus rj conjugate is a real number, the imaginary parts cancel, and rj into rj conjugate is the modulus of rj whole square, so it's also real. So we get here a real polynomial of the form x square plus px plus q, where both p and q are real. So whenever we have a complex root, since its conjugate is also a root, so we can combine them to get a factor of this kind, x square plus px plus q, which is a degree 2 factor. And whenever we have a real root, we will have a linear factor of the kind x minus r. So fx can be factorized into polynomials of degree 1 and degree 2. It's a good point to start.